I said easy day today. Although probability does tend to get a little bit more complicated as we move along. Okay. But if you sort of remember the rules, you can figure out the problems. And so we're almost to the point where we're ready to start actually doing complete statistics problems, like complete analysis and conclusions. But a lot of the conclusions we make in statistics are based on probabilities. So we need to be familiar with probabilities before we move on to that last stage. So today, all we're really going to talk about is simple probability. And you should all be familiar with this. Like if I flip a coin, what's the probability that I flip heads? 50%, 1/2, 0.5, they all mean the same thing. If I roll a 6-sided die, numbers 1 to 6, what's the probability that I roll 3 or less? What's the probability that I roll more than 5? How much? More than 5. That I get a number greater than 5. Yeah.
What?
You guys, I'm rolling a single die. What's the probability that I get a number greater than 5?
Oh, 2 out of 6.
1 out of 6.
Oh, I said that.
Okay. What's the probability that I roll a 7? Right. Okay. All right. So probability of an event, how many ways an event can occur over the total number of possible outcomes. And we use this formula, this simple formula, when the outcomes are all equally likely. So here we have another example. We've got 8 red marbles, 12 blue marbles in the jar. What's the probability of selecting a red marble? So the event R is selecting a red marble, and using probability notation, we're asked to find P of R. So using proper notation, we would say, okay, the probability of red equals, and what is that? 8. Yep. And the nice thing is, we don't have to reduce. Okay? You can, it's still right, but you don't have to. You can leave it as 8 out of 20. Or you can change it to percent, or you can write it as a decimal, because all of those are equivalent to each other. First rule we're going to talk about is the complement rule. And the complement is the probability of some event not happening. And we use this notation, whatever the event letter is, with a C, capital C, like an exponent. Okay? And how do we find it? Well, we find the probability of everything happening minus the probability of that one thing. And that would represent the probability of it not happening. So for example, if I said probability not red, and that's what that means. Well, the probability of everything happening is 1, or as a percent, it's 100%. But if we're dealing with fractions, it's 1. So it would be 1 minus the probability of red happening. Which would give us 12 out of 20. And again, you can leave it like that. What represents a valid probability model? Well, a couple of things before that. Probabilities are always between 0 and 1. If you're writing as a fraction or decimal, 0%, 100%, if you're writing as a percent. And the probabilities of all possible events in some situations will equal 1 or 100%. So if we're given a question and we're asked to determine whether it is a valid probability model, first of all, we have to fill out the probability model, and then we have to make sure that these conditions are met. So again, okay, so we're back to a bag of 20 beads. They're a mix of clear, solid, red, green. There are 6 clear reds, 8 red solids, 2 clear greens, 4 green solids. So what's the probability we select a clear red? 6 out of 20. Solid red? 8 out of 20. Clear green? 2. And finally, solid green? 4. So that's our probability model. The question is it valid? Okay, well, first condition is met. All probabilities are between 0 and 1. That's met. And if we add the 4 probabilities, does it equal 1? Yes, it equals 20 over 20, which is 1. So all probabilities add to 1. So these 2 conditions mean it is a valid probability model. Thank you. Referring to that example we just did, if we call the event, you select a solid red, that's Q. If you select a red, clear or solid, that's R. So what's the probability of Q? Red solid. What's the probability of red? 14 out of 20, because it's 8 out of 20 plus 6 out of 20. Because there's 2 types of red. So you get 14 out of 20. Not Q. Yeah, 1 minus this, which is 12 out of 20. Six out of 20, because it's 1 minus 14 of 20. Okay. Okay, couple of things to finish this up. Something called the law of large numbers. Basically, probability is unpredictable in the short run, but predictable in the long run. So after doing something many times, something will approach its actual theoretical probability of happening. Like if you flip a coin 1 time, okay, you get heads, that means heads is happening 100% of the time. That doesn't make any sense. But if you flip it twice, maybe you get heads, then tails. Now heads is happening 50%. Then maybe the next one is heads, then tails, then tails. Now it's happening 33.3%. But as you keep increasing the number of trials, like it's going to kind of move all over the place, and then it's going to settle to its actual theoretical probability. Okay? So, law of large numbers.
after many trials,
The relative frequency, okay, or the percent or the proportion.
will approach their actual probabilities. I didn't really feel like I really want this. So here's one with heads. Fortunately, this coin flip tablet doesn't seem to be accessible anymore. So like if you're recording the probability of getting heads, clearly you can see after the first trial, we didn't get heads. But then we must have got heads again, and then as it goes down, we're getting more tails. But now we're starting to get more heads, and it's coming up to approach its actual probability of 0.5. Okay?
So that's an actual law, a probability law.
Something that is not a probability law.
Is the law of averages.
So for example, here's two situations
Where we flip the coin 10 times.
you can see it's pretty evenly spread out in the first time we do it. But in the second time, boy, we're getting a lot of heads. In fact, we got what? 7 in a row in situation 2. What's the probability of getting heads on the next flip here? And here? Right. It does not change. The coin has no memory. Okay? The probability of getting heads or tails is 50% here, and it's 50% here,
Even though we got heads a bunch of times.
This is what gamblers like.
It's like I've lost on the roulette wheel 12 times in a row. The next one has got to be a winner because I've lost so many times.
So, what's the probability? Equal chance of tails. In both situations.
I buy 2 Lotto 649 tickets every time there's a draw. On Saturday's draw, I won nothing, which means I've got to win something on Wednesday. Has to. And if I don't win on Wednesday, boy, I got to mean I win next Saturday. You think as a mathematics teacher, that teaches probability, I would know better, but clearly I don't.